Okay, so this is some sort of chapter 21, I believe. Respiratory, we should put it on these. I have like hair that migrated into my bangs and it's just annoying me. Respiratory diseases. So this is, of course, going to include the obvious ones like influenza and stuff, and some other ones that you may have forgotten about, but you should have heard about. The respiratory diseases, what do I say? No, I'm just getting the defenses. Defenses for the respiratory system include, of course, your nasal hairs, the cilia in your actual like lower respiratory tract. You're supposed to help move the mucus and everything out. That's important. We have coughing, but that's supposed to be moving out. The presence of mucus. We have alveolar macrophages, and then secretory IgA. Man, secretory IgA, anytime you have mucosa, secretory IgA is there to help you out. So a lot of these have that, okay? Let's not forget our good old friend, secretory IgA, associated with the mucosa. Alveolar macrophages are macrophages that are specialized to the alveoli, the little sacs inside of, your lower respiratory tract, your lungs. That's the word. So starting off, pharyngitis. That is inflammation of the throat, the pharynx. We talked about Streptococcus pyogenes. So it can be caused, pharyngitis can be caused by a variety of things. Typically, bacterial pharyngitis tends to be more painful and more uncomfortable. I don't know. Than the viral, that's what I'm trying to say. It's just so you know what, compared to what, than the viral versions. Remember we had talked about Streptococcus pyogenes and how it has like erythrogenic toxin. There's other toxins that it has too, like streptolysin. But basically those toxins are going to make it more virulent and more able to cause pathogenesis or disease in the host. And it is lysogenized in some cases, meaning that there is a bacteriophage that infected it, incorporated its DNA into the bacterial DNA, inserted its little self in there, and then they became one. And associated with it was some sort of gene that allows for production of an erythrogenic toxin, which is going to be the causative agent for causing a rash in scarlet fever. Yes. So that's Streptococcus pyogenes, and it causes some diseases. Next is diphtheria. Yeah, we don't really see this very much, but it does exist. It is out there. It is caused by the bacterium Corynebacterium diphtheriae, and it can cause this pseudomembrane in the throat that can completely block off respiration. We do vaccinate for this using the Tdap vaccine. It is included with tetanus and pertussis. So that's mostly going to be associated with the toxin, the diphtheria toxin. That's what I'm trying to say. Okay, so that's diphtheria. Sore throat essentially with the pseudomembrane that can cover the whole throat. Next is whooping cough. Whooping cough, we also call this pertussis. It's caused by the bacterium Bordetella pertussis. It does cause very severe, coughing, and it has these 3 phases that are associated with it. I don't remember what the first stage is, but it's basically cold-like symptoms. Then we have the Cotterell phase, and that is basically when you're gonna have that severe coughing that's associated with it, and that is the 100-day cough, and cough and cough and cough, and it produces toxins as well. The whooping cough, the bacteria does, which is what we're vaccinating against with the Tdap vaccine. Those toxins essentially going to lead to damage of the cilia that were going to help the mucus move out, as well as production of mucus. So you have a lot of production of mucus, and then you can't move it out to get it out of your chest. So you just keep coughing and coughing and coughing and coughing and coughing. And even whenever you have gotten over the illness and, finally your cilia can start recovering and everything, it has caused severe damage that can lead to sequelae as well as secondary infections. So infections that can cause due to the respiratory system being a problem. Now, we don't hear a lot. So when I say that this causes severe coughing, this is the kind of cough, like if you've ever like coughed and 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 coughed, and it's like you can't even breathe in because you just keep like that, but just not even like that, like really coughing, and you just can't breathe in. And it's like you breathe in finally, you're like, and then you just start coughing. That's this for days. So it just goes on and on. So this is serious. This is pretty bad. Elderly folks can get it and not have particularly serious symptoms, adults as well. You have to keep up with the vaccines for this. They do wear off. The problem with all of this, of course, is that if you are an adult and you do get this and it's not particularly bad, and you go visit your brand new baby niece and you go hold her and you pass on your pertussis to your little baby niece that hasn't been vaccinated yet, it can be deadly to babies. This is where it becomes a problem in the United States still. Very serious. Okay, so influenza, let's just go into that. It's obviously a virus, right? So we know the flu virus is caused by a virus, influenza virus. We talk about H1N1 or H5N1, the H whatever, H number, N number. The H stands for hemagglutinin. The N stands for neuraminidase. Hemagglutinin is for attachment to like your host cells whenever you're getting infected. Neuraminidase, it's used by the virus for a lot of things, for budding, to clip it free from the host cell that it's budding out of, for fusion with the host cell, breaking down mucus so that it's easier for the virus to get into cells, and then keeping the viruses from sticking together whenever we have production of new viruses. You don't want them to stick together, you want them to stick to the host cell that is trying to infect. So that's the function of those. They're not just H's and N's for no reason. It represents something pretty serious about these viruses. Tamiflu is a drug that will keep neuraminidase from working. It like sort of interferes with its ability to do its job. So that's how Tamiflu works, and Relenza, I believe. Then we have antigenic drift versus shift. We know that viruses are going to mutate a lot. They replicate very, very quickly, and a whole lot of them. So it makes sense. They're not super perfect about making sure that mutations are taken care of, because it's advantageous for them to have advantageous mutations. So antigenic drift is dealing with, spontaneous random mutations that can occur and therefore lead to variation in the viral particles. That can lead to us needing to have different vaccines. Then we have antigenic shift. And what antigenic shift is, we have infection of like a reservoir animal with one type of virus, like the swine virus, and then maybe we get the bird flu virus, and they infect one pig. And then whenever we're making new virus particles, we can package up parts of genome from pig and parts of genome from bird flu viruses. Okay, and there's the flu virus has segments, so you can have like different segments that you can mix and match up when you have co-infection within one organism. And then that can go on, that newly mixed up brand new virus that we've never seen before can go on to infect people like we've never seen it before. And that's why we need to have vaccines. We really need to have vaccines. So that's fast, right? We get major big changes quickly by antigenic shift. Combination of these two is usually what's happening all the time. And so we have to try to predict every season which ones are going to be the most common, which ones we're going to see, essentially. So it's not perfect. All right, next we're going to talk about pneumonia. This is another syndrome. The most common cause of community-acquired pneumonia. So community-acquired is just non-hospital acquired. The most common cause is going to be Streptococcus pneumoniae. We mentioned this before when we talked about meningitis, right? So this guy is the most common cause of community-acquired pneumonia, as well as meningitis. The second most common cause is going to be various viruses. Third, we have mycoplasma. These are usually associated with walking pneumonia. And then we have other random bacteria that can be associated with pneumonia, like Legionella or Legionnaire's disease. This was a sick building syndrome where essentially the water towers got I won't say infected, but yeah, I mean, there were, we had the bacterium growing, the Legionella bacterium growing in the water towers of the building. And that got spread to the elderly smoking gentlemen that were, having their Legion meetings or whatever. So it's like the American Legion or something. So whatever, that's what it's named for. Then we have hantavirus. This is hantavirus pulmonary disease, a pretty severe disease. Mice can transmit this. So this is going to be urine and feces that kind of dry up, and then you go sweep, and then it gets put into the air and you breathe it in and you get hantavirus pulmonary syndrome. Next, we have Haemophilus influenza and Histoplasma capsulatum. Both of these are associated with HIV patients and those with lowered immune systems. So those are pneumonia that are not associated with hospital stays. Healthcare associated, we have a combination of different bacteria. It still includes some of these, and then other ones as well that we didn't mention, like Klebsiella pneumoniae and other things. But it's usually more than one at one time causing it. The common cold can be caused by a variety of viruses, like 200 different viruses, more than 200 actually. And they often lead to bacterial infections, like secondary bacterial infections like sinusitis. Yeah, I mean, the inflammation, everything just opens you up to be more likely to be infected by bacteria on top of the viral infections that you have for the cold. Then we have tuberculosis. Tuberculosis, about a third of the world is infected with tuberculosis, no joke. It's caused by the bacterium Mycobacterium tuberculosis. We diagnose this by that tuberculin skin test. The thing about that is that your T cells, remember your I can't believe that. I'm acting like you guys never heard of it. Your T cells, your cell-mediated immunity, like your cytotoxic T cells, your CD8 positive cytotoxic killer T cells. Those guys, when we have those that have been made by your body against tuberculosis infection, it has like a hypersensitive reaction to the tuberculosis bacteria, and they live inside of cells. So they live inside, they are an MHC1 type of an organism. And so we make our CD8 positive T cells in response to them. So if you have memory CD8 positive T cells to Mycobacterium tuberculosis, when we put that bit of PPD tuberculin under your skin within 48 to 72 hours, because it is like a type 4 hypersensitivity, cell mediated, so it's going to take a couple days. But within 48 to 72 hours, we will look at the results of that. And if it is swollen up and puffy, that means that you have had a CD8 positive cytotoxic T cell response to that stuff that we put on your skin. And you may have been infected with Mycobacterium tuberculosis. So they do further tests to confirm that. So that includes a chest x-ray, of course. If you've had tuberculosis, you will have scarring that is obvious in your chest. That's just part of the process of being infected with tuberculosis. Having these granulomatous tubercles, they call them, but they can become hard and calcified. But first they'd be caseous, which is sort of like cheese, because it's sort of like it's rotting, because it forms these granulomas that become dead on the inside, and then those can, whatever. So at first you get all that happening, and you can become latent, and that can just mean that you're not having any symptoms of tuberculosis. Later on, when you have a lower immune system, it could come back out, and we could have liquefaction of those tubercles. So those little caseous areas where we had the growth, when we're trying to wall off all the tuberculosis and everything, ones that haven't healed and gotten hard and calcified, and you're still carrying it, can become liquefacted, which just means literally like liquidy. And those can rupture open and leak into other areas of the lung, and more inflammation and so on and so forth. And that inflammation associated from the spread around in the lung is what's going to be causing coughing up stuff and coughing up blood, and leading to consumption, essentially, which is losing weight and becoming anemic and becoming anorexic and all of the stuff that's associated with having, what we think of as typical tuberculosis. So we'll do a chest x-ray to look to see if there's any evidence of that, because you would have some if you're positive. And then we can also collect a sputum sample if we're concerned that you have tuberculosis. So we'll get an acid fast stain. We can stain it directly, your actual sputum sample, or we can culture it. So that's tuberculosis. A third of the world has it. It's no joke. We have it here in the United States. That is it for the respiratory diseases. That's really quick. Yeah, let's move on to what is it next? GI. Chapter 22 is GI system. Yes.